light. In today's section, we are discussing about the light chapter. Light is the source of energy, which is the sensible organs visible to an object. The light is a source of energy. Light is the source of energy which sensible as visible and objects. The light has the two properties. The kinds are the reflection of light, and the one is refraction of light. First one is the reflection of light. Reflection of light. If a light falls on the shiny surface, it bounces back and go in the same direction. Such a phenomenon of the light is called a reflection of light. Suppose if it is the shiny surface, X and Y is the shiny surface. If the light falls on the XY shiny surface, it bounces back and reflected in the same direction. Such a phenomenon of light is called refraction of light. If you draw the normal to it, if the angle of incident, which is the angle of incident, which is represented by the R, angle of incident is always equal to angle of refraction. Angle of incident is equal to angle of refraction. It has the two laws of the refraction. In the first session, we know about what is the refraction of the light. In the today's session, we want to know about the laws of the reflection. If a light incident ray falls on the shiny surface, it will get the reflected. We draw the normal to it. If the incident angle and refracted ray, and we are drawn normal, all are on the same plane like this. The sum of these two are the 180. The incident ray and reflected ray and normal at the point of the incident all lie on the same line. If the incident ray is, which is the surface of the XY, incident ray is R, refracted ray is R. Incident ray falls on the XY and it gets reflected through R. You have to draw the normal. All I and normal and refracted ray all are lie on the same plane, which is the first law of reflection. Second law, if the angle of incident is equal to angle of refraction. If the angle of refraction is drawn, you have to draw the normal. If the I, here I means the angle of incidence, which is always equal to the angle of refraction. Yes. The next kinds of the light is the refraction of light. Refraction of light. If the light travels from one medium to another medium, if there is a glass in between the light traveling, the light travels from one medium to another medium, it bends its direction. That phenomenon is called the refraction of light. Laws of refraction. If a light travels from one medium to another medium, we already know that it changes its path. If the glass in between the light medium, if the light travels from the light, it bends towards normal or away from the normal. This phenomenon is known as the refraction of light. The refraction of light also have the two laws of the refraction. The incident ray and refracted ray and the normal are on the same surface. If it is the incident ray I, which is known as the I, and which is reflected like this, which is reflected, we have to draw a normal. The incident ray, normal and refracted ray or lie on the same surface. And the second laws of the refraction is, if the ratio of sin I means the incident ray, then sin R means the refracted ray, the ratio of sin I and sin R remains constant for any two media. This is the denser medium, and which is the rarer medium. The sin I, which is tends to sin's log, sin angle I divided by sin angle R is equal to mu. This mu is called the refractive index. Then one of the nature of light is the total internal reflection, which is used in the day-to-day life. If the light falls on the any shiny surface, it will get reflected. We know that the reflection. If the the total internal reflection, light traveling from the optical medium to denser medium, light gets reflected in the same direction. This phenomenon is called the total internal reflection. Total internal reflection is used in the day-to-day. That is called the application of TIR. Here TIR stands for the total internal reflection, which is used in the medical endoscopy, traffic signals, and it forms a mirage. These are the applications of the total internal reflection. Scattering of light. Scattering of light. Light splits in the R direction. This phenomenon of the nature of light is called the scattering of the light. If any collider particles comes in place of the traveling path of the wave, the light gets into reflected. This phenomenon or this nature of the light is said to be the scattering of the light. Due to the scattering of the light, the sky is visible in the blue color. Sky is blue due to the scattering of light. Due to scattering of light. Then also it is also forms a Tyndall effects. These are the some applications of the scattering of the light. First one is the sky is visible in the blue color because of scattering of the light. The next one is in the form of the Tyndall effect. The next nature of light is the atmospheric suppression. The Earth having the layers. First one is the biosphere, stratosphere, ionosphere, and exosphere. Due to the layers present on the Earth layer, the light gets refracted. Due to this phenomenon of the light is called the atmospheric refraction. Due to atmospheric refraction, the stars do not spread twinkling actually. Due to the atmospheric refraction, the lights are the twinkling. Then it will be appears the advanced sunset because of the 2 minutes. In the time of the 2 minutes, it rise the advanced sunrise and delayed sunset after the 2 minutes. If you are the sunset in the today's sunset is on the 6 AM actually, because of this it appears to me it is the 5:58 AM due to atmospheric refraction. If the today's sunset is born in the 6 6 a.m. But it spurs me, it sees me after the 2 minutes. It is the 6 hour 2 minutes. Then due to atmospheric refraction, stars seems to be the higher than they are actually are. They are seems to be actually are the smaller in the naked eyes, but due to the atmospheric refraction, they are looking so bigger than because of atmospheric pressure. Yes. In the next condition of the lights, it's used in the mirror. There are the two kinds of the mirrors are present in the nature. First one is the plane mirror. If the reflecting surface is the plane, like this, such mirrors are called the plane mirrors. The plane mirrors are used in your home and the barber shops. The next one mirror is the spherical mirror. If the mirror's reflecting surface become the curved inwards or curved outwards, of the reflecting surface mirror are called the spherical mirror. In the spherical mirror, again we divide into the two types. First one is the convex mirror. In the convex mirror, its reflecting surface is curved outwards like this. If the reflecting surface of the mirror is curved outwards, such mirrors are called the convex mirror. Also, convex mirror is called the diverging mirror. So next type of the spherical mirror is the concave mirror. If the reflecting surface of the lens, curved inwards, such mirrors are called the concave mirrors. If the reflecting surface, which is the inwards, like this, reflecting surface is the outwards, is called the convex. Reflecting surface curved inwards are called the concave mirror. Then mirror formula. We have used to mirror formula to find the distance of the any image. Mirror formula, which is very easy to remembering. That is 1 over f divided by 1 by u minus 1 by v. 1 by f is equal to 1 by u plus 1 by v is the mirror formula.